Hey guys, how's it going? Mr. Mitchell here. In this video we're going to go over 3 worked examples to show you how to do problems involving conservation of energy. Now if you haven't already done so, check out my previous video covering the theory on this topic, and that way you can apply what you learned in that video to this one. So let's get started. Question 1 says Tom Daly with a mass of 75 kilograms jumps off a diving board. Part A says what type of energy does he have at the start? Well, at the start he's on the diving board, which is a certain height above the surface of the water, so that means he has gravitational potential energy to begin with. Part B then says what type of energy does he have just before he hits the water? Well, when he jumps off the diving board, his gravitational potential energy is going to be converted into kinetic energy as he's now moving. So he has kinetic energy just before he hits the water. Part C then says if he hits the water travelling at 14 meters per second, find his kinetic energy. Well, we know his speed and we know his mass, so we're going to use the kinetic energy equation. So we're trying to find EK, the kinetic energy. The mass M is 75 kilograms and speed V is 14 meters per second. So we can write down the kinetic energy equation EK equals a half mv squared and substitute in the numbers. So we get a half times 75 times 14 squared, and putting that into your calculator should give you an answer of 7,350 joules. Lastly, part D says calculate the height of the board above the water. Well, here we need to use conservation of energy because we know that Tom Daly at the start had gravitational potential energy and this converted it into kinetic energy. So we can say that by conservation of energy, assuming air resistance is negligible, i.e. we can ignore it, then we can try and find the height h. We know the mass m is 75 kilograms and the gravitational field strength G on Earth is 9.8 newtons per kilogram. And lastly, the kinetic energy we just calculated was 7,350 joules. So writing down an expression for conservation of energy in this scenario, we have the loss in gravitational potential energy is equal to the gain in kinetic energy. So that means we can write the gravitational potential energy as mgh, and that's equal to the gain in kinetic energy which we calculated in part C, 7,350. So substituting in the numbers now gives us 75 times 9.8 times h is equal to 7,350, and then to get h on its own we just divide both sides by 75 times 9.8, and putting that into your calculator gives an answer of 10 meters for the height. Question 2 says a steel ball bearing of mass 0.6 kilograms is released from a height of 14 centimeters on a track. Part A says to find the gravitational potential energy EP. Well, writing down what we know from the question, we're trying to find EP. We know the mass M is 0.6 kilograms, gravitational field strength G on Earth is 9.8 newtons per kilogram, and that's from the datasheet. And lastly, the height h is 14 centimeters. But remember, we don't want height in centimeters, we want it in meters. So we're going to convert this into meters by dividing by 100. So we can say that 0.14 meters, and writing down our equation for gravitational potential energy, we have EP equals mgh. Substituting in the numbers gives 0.6 times 9.8 times 0.14, and putting that into your calculator should give you an answer of 0.82 joules. Part B says what is the kinetic energy of the ball just before it leaves the track? Assume there is no friction. Well, remember, if the ball has gravitational potential energy and it's released from a certain height, then that energy will be converted into kinetic energy as the ball moves. So we can say that by conservation of energy, assuming no energy loss is due to friction, that the loss in gravitational potential energy is equal to the gain in kinetic energy, just like we did in question 1. So therefore we can say the gain in kinetic energy, or simply just the kinetic energy EK, is equal to 0.82 joules, which is the value of the gravitational potential energy we found in part A. And remember, we can only say that these energies are equal by assuming no energy losses. Lastly, part C says to find the speed of the ball as it leaves the track. Well, writing down what we know from the question, we're trying to find the speed V. We know the mass M is 0.6 kilograms, and the kinetic energy EK is 0.82 joules, which we just found in part B. Writing down our equation for kinetic energy, we have EK equals a half mv squared. Substituting in the numbers gives us 0.82 is equal to a half times 0.6 times v squared. We can now simplify the right hand side to get a half of 0.6 is 0.3 times v squared, and then we can divide both sides by 0.3 to get v squared on its own. So that gives us v squared equals 2.73, and then we can take the square root of both sides to get v on its own, and if you put that into your calculator you should get an answer of v equals 1.7 meters per second. Lastly, question 3 says a weightlifter applies a force of 500 newtons to lift a barbell 1.2 meters from the ground. Part A says what is the work done to lift the barbell? Well, writing down what we know from the question, we're trying to find the work done EW. We know the force F is 500 newtons and the distance D is 1.2 meters. So writing down the equation for work done, we have EW equals F times D. Substituting in the numbers gives us 500 times 1.2, and putting that into your calculator should give you an answer of 600 joules. Lastly, part B says, what is the mass of the barbell? Well, here we're thinking about a barbell that's being lifted from the ground to a certain height. So work is being done to lift the barbell and give it gravitational potential energy. So that means we can say that by conservation of energy, assuming no energy losses, that the work done is going to be equal to the gain in gravitational potential energy. And writing down what we know from the question, we're trying to find the mass m. We know that gravitational field strength G is 9.8 newtons per kilogram on Earth from the datasheet. The height h is 1.2 meters and the work done EW is 600 joules, which we just found in part A. So writing down an expression for conservation of energy in this scenario, we have the work done EW is equal to the gain in gravitational potential energy because we're doing work to lift the barbell to that certain height of 1.2 meters. And then we can replace the right hand side with the expression for EP, which is mgh. So we have 600 is equal to mgh, and then we can sub in the rest of the numbers to get 600 equals m times 9.8 times 1.2, and then to get m on its own we can divide both sides by 9.8 times 1.2, and putting that into your calculator should give you an answer of m equals 51 kilograms. That's all for this video folks, thanks for watching. If you made it to the end, I really appreciate it. Make sure to give the video a thumbs up, subscribe to the channel, and I'll see you in the next one. Take care.